All right. So the plan today, we're going to go ahead and begin 2.14. What we don't finish, we will take care of tomorrow. I'll also pass back the quizzes tomorrow. We'll talk about any questions you might have on those. And then that's going to finish up our week. We'll be on SEL. Don't forget that Monday, the 2.13 assignments due. The key is already posted to the website. How many people have watched that video? That number 5 I recorded from the notes? How many people are going to watch it tonight? I appreciate you at least saying that. Okay. And then we'll start 2.15 on Monday. That is our final lesson of the year. After that, we are on review. May 13th, Tuesday is coming up pretty quick, so we want to make sure we're ready. Okay, well, let's go ahead and do it. Here is 2.14, log function context and data modeling. So what we're going to be doing today is algebraically and on technology, we're going to be finding logarithmic equations for sets of data. Okay, so just as we've seen with other types of functions, linear, quadratic, exponential, many real-world scenarios follow a logarithmic pattern outside the salary data and the graph above. So that graph we're going to reference again in just a moment. Logarithmic patterns are found in the way we measure earthquakes, sound, acidity, etc. As a result, we have a need to create logarithmic models for the data. So let's see what this box says. For a given set of data, if the input values appear to change proportionally over equal length output value intervals, then a log model is appropriate. And we've been talking about this over the past couple of weeks. Here's an example that I pulled from a previous lesson. So the x's are changing proportionally, or as we say, change multiplicatively, and the y values are evenly spaced. Remember, that was going to be a logarithm. If I switched those two patterns, remember that was an inverse exponential. Okay, well, let's get right to it. So selected values of the log function L are given in the table above, where L of x equals a plus b times the natural log of x. Part A, use the given data to write two equations that can be used to find values for a and b. Okay, so basically we're going to create a system, and then in part B, we're going to find what those values are. Now, we did this previously with exponential, and just like then, we're going to go ahead and incorporate this function notation. So my first x value is 2, so I'm going to go ahead and say L of 2 equals. Now I'm going to go to my general form. We have a plus b times the natural log of 2, and if I input a 2, that output is a 3. Okay, so there's my first equation. So the second one would be L of 5. So this is a plus b times the natural log of 5, and that's going to output a 7. Okay. In fact, you're going to have an FRQ that starts off very similar to this, but we have a little bit more to talk about that later. Okay, and in part B, let's go ahead and figure out what the values are. Now, let me go ahead and write my system again. So we have a plus b times the natural log of 2 is equal to 3. And then a plus b times the natural log of 5 is equal to 7. Now, there's a lot of ways that you could go ahead and solve a system of equations. We're going to go ahead and run with elimination. In fact, I'm going to go ahead and immediately subtract the two equations, because which variable is going to get eliminated? A. Yeah, a minus a, they just cancel each other out. Now, for the b's, though, we have b. Oh, that's interesting. We have b times the natural log of 2 minus b times the natural log of 5 equals 3 minus 7, negative 4. Now, we are going to turn to the calculator in just a moment, but we're not going to approximate these two logs to go ahead and combine them. Let's say that b is our GCF. So I'm going to divide the b out. This is going to give me the natural log of 2 minus the natural log of 5 is equal to negative 4. Now, I can easily go ahead and divide right now by the binomial and get my answer, but we can go ahead and make this a little easier on us. If I have two logs of the same base separated by subtraction, do I combine those arguments by multiplying or dividing? We're going to divide. So I'm just going to go ahead and combine this expression. So we got b times the natural log of 2/5. 2 is on the top because it was the first one written. Equals negative 4. Is everybody okay with what I've done so far? Okay. Now let's divide through by that natural log. Okay, the natural log of 2/5. Those are going to cancel. So this is going to give me half of what I'm looking for, B. All right, so let's come on over here to the calculator. Control divide. So I got a -4 over. Now, control 10 to the x right next to 1, that'll give you a log. But if I hit control and then e to the x right next to it, that will give me the natural log that I'm looking for. And then I want 2 divided by 5. So it looks as though b is 4.365. Okay, so 4.365. Okay. Now, just like any other system, I'm going to take this value and find what? Still got to find A. Now, it does not matter which equation we go ahead and use. They're both going to give me the same value. Let's just go with the top one. So A plus, we know B is 4.365 times the natural log of 2, and this will equal 3. Now, just one word about this real quick. I did round so that I could go ahead and write my answer for the first variable on my paper. But when I go ahead and find A, I'm going to use the exact answer in the calculator. Remember, I don't want to round in the middle of the problem because that will kind of skew the value for A. Okay, so all I got to do is take this value of B. Let's go ahead and multiply it by the natural log of 2. So times the natural log of 2. Okay, so A plus this number equals 3. So I'm going to go ahead and take 3 and subtract this. Okay, so this is what I'm getting for A. Let's say a negative 0.026. There we go. Okay, now if I take both those values and plug them into my general form, here is the equation for L. Negative 0.026 plus 4.365 natural log of X. Okay. Questions? Not too bad. Okay. All right, so we did one algebraically. Now, number 2, we're going to go ahead and use the calculator. Okay. So the table above gives the data from the graph at the beginning of the notes. So if you look at the previous page, that scatter plot, this data is where that scatter plot's coming from. So it relates church size and the average salaries of pastors in the U.S. So part A, use the regression capabilities of your calculator to find a logarithmic function model for the data above in this form. S equals A plus B times the natural log of P, where P is the church size and S is the average pastor salary in thousands. Okay, so I'm going to take this with me because I am not going to remember all those values. So let's see if you folks can help me remember all the keystrokes. Okay, because we've done this for linear, quadratic, exponential, sinusoidal. We just have not done it for a log yet. Okay, let me go ahead and document B out here. Okay, so I'm going to go ahead and go home. What do I choose? Oh, not yet. We got to put the data in first. Okay, so I need to go ahead and choose 1 because we're looking for lists and statistics. Now, if anything is in your calculator, remember, just go ahead and say, no, we're not going to save that. Okay, so lists and spreadsheets. All right. Now, we're using S and P, but I always like to default back to X and Y. Remember to avoid the equals row. Okay, and let's put in the first column here. So this is the church size. So 75, 120, 250, 300, 450, 650, 900, 1500, 2500, and then 5,000 people. Okay, so I got my data in for the first set. Control 7. Now the average salary in thousands, so 42, 58, 70, 79, 88, 95, 110, 125, 138, and 175. Okay, so I got my data in. Okay, anybody need help? Okay, I'm going to go back home. Now where do I go? Data and statistics. Looks like it's like a bar graph. Okay. Now, you can use your touchpad and your mouse to go ahead and tell it where to put the axes. I like to use the tab button. Okay. So tab, there is the first column X. So we'll always take care of the horizontal first. And then tab, the vertical Y. And that is the scatter plot that's on the front of page of your notes. Okay, that's where that came from. Okay. All I got to do now is have it draw the curve and provide me the equation. How do I get that? Menu. Okay, we're going to go to Analyze, Regression. There we go. We want a logarithm. Okay, so there's my curve, and here is my form. Okay. So I went ahead and took it to 3 decimal places. So when I come back over here to my notes, when I move that, there's the function. Negative 91.542 plus 29.909 natural log of p. Okay. Questions? All right, we got 1 part left, and then we are done. What time are we out of here? 3:25? Oh, see, we're doing really good. We're doing so well, you'll probably want to keep going, right? Exactly, I see a bunch of stuff. Okay. B, use the model found in part A. What is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people? Okay, so remember the number of people was P, so we're just going to plug that in. What do we got here? Negative 91.542. Okay, let me go back over here. Negative 91.542. Oh, I want a negative. There we go. No, point. That's weird. Plus, what was it? 29.909. Okay. Times the natural log, and we're looking for 500 people. Okay. So here's my function. I plug in my 500. So it looks like 94,331. Okay. So a little over $94,000. Okay, according to this model, is the annual salary of a pastor with 500 folks. Okay. All right. Questions? Anybody having a hard time? Okay, we got 1 problem left. We'll do that tomorrow. Oh, I mean, if you want to, we can do it. You sure? Okay. So we will do that first thing tomorrow. We'll go ahead and talk about the 2 quizzes, and we're on SEL. We're done with another week. Okay.